From an SR safety review panel perspective, Stowage has come to the panel on several different occasions. And when it first came out, it was about complying with the station shuttle requirements. We had allocated stowage. How did we make sure that stowage got put in its right places? And it was an inventory tracking issue. And it wasn't presented as a major safety concern to the ISS. But as time progressed, the stowage problem became larger and larger. We had equipment that was launched, not used. We had equipment that got lost and misplaced because it's in the inventory management system. We had consumables that were not consumed. We had trash. And all of this were pressures to increase the amount of space that we needed. So suddenly it wasn't an issue of do I have compliance with stowed hardware meeting the ICD requirements for the rack stowage locations, but now it's where do you put the items. So once they started putting the items, they had to do the hazard analysis and say what is the impact to the overall station of stowing these items. And when they did that, they found out that it impacts a lot more than what people would on a short notice think of what stowage is. It impacts habitability of the station. It has an enormous impact on operations. It has an impact on safety. And actually the operations impact is probably the largest impact, and you hit that operations impact long before you start infringing on safety concerns. But it does impact safety, as I'll discuss in a moment. With respect to operations, the big problem is that you put something down, and if it's not where it's supposed to be, it's either covering up something that you want to utilize later, or you have to move it to do an operation in that location where you had, because it wasn't planned to be in that location. And when we first started off with station, all of the stowed equipment was supposed to be stowed in designated racks. When we outfitted station, we needed critical spares. We brought them up. Our consumables were larger than we had thought. And we noticed that the Russian plan for doing this was to strap things in the front of panels. Well, when we ran out of stowage locations, we ended up copying the Russian method and started bungeeing things to rack faces. Of course, the rack faces were never designed to withstand the loads from stowage, so we had to deal with that. So we had some mistakes along the way. We bungeed things to little D-rings that were on some fasteners, and the D-rings flew off. That presented a projectile hazard that we had to deal with, and therefore find better ways to attach them. But from a safety perspective, stowage impacts operation of critical systems more than anything else. If we had a gas sampling system, have we affected the validity of the data for gas sampling? Therefore, do we know we have the atmosphere we planned on? It affects airflow throughout the station because the original volume wasn't the volume that we analyzed. We have fire ports throughout the station, and they're on every rack. So if you start using rack faces to put stowage equipment, that invalidated access to those, ready access to the fire ports. You also have emergency equipment on board station. We were blocking portable fire extinguishers. We were blocking PBAs, portable breathing apparatus. So suddenly non-compliances were coming in saying we don't have ready access to these. So we were given orders to fix, at least the safety panel gave the hardware providers the direction to remove these items and clear up these non-compliances with ready access. Well, we fixed those, and the first thing that happened was the crew says, hey, it's taken me an awful lot of time to move these to other locations, and I'm being forced to move them multiple times because I'm taking them from one location to another location. And I remember having a discussion with the program manager saying, is this an issue I want to fall on my sword for? Because yes, it's never supposed to be stowed in front of blocking a fire port, but we can accept an increased amount of time to get behind the fire port, move the item and get to the fire port in response to an emergency. So we had to make a safety compromise, and that is increased time to respond to an emergency because of this lack of planning for stowage. Critical spares is another one. We have, if you look at how we design space station, we certified for safety large modules one at a time. And every one of those modules have hundreds of ORUs. And the original safety analysis and certification had to do with the launch configuration and use configuration of those hardware. But as the hardware ages, there are going to be failures. And when those failures occur, you're going to want to go change out those ORUs. In some cases, we'll have the spares on orbit, which is something you got to account for in stowage. Or we have to have the spares brought up. We have to bring up spares we never intended to have because of on-orbit failures. We have to bring up tools we never intended to have, and that impacts stowage. The stowage problem ends up being very cyclic. When a cargo vehicle arrives, you get a large influx of cargo that has to be staged in temporary locations and ultimately put away in found places for it to be stowed. So when an orbiter arrives with an MPLM, there's a timeline the crew has to follow. So they have to have that MPLM emptied in a very short period of time, which usually means the area right outside the hatch is filled with logistics items that have to be unpacked and then stowed someplace. And then you have the hardware to be returned has to be put back in the MPLM. So I have a lot of hardware that's loose, that's in transit, that doesn't have a location at that particular time. So there's a large impact to aisle space, to passageways, and critical equipment. So you're going to have to make allowances for this temporary staging of equipment when the cargo vehicles arrive and when the cargo vehicles depart. And for the departure, the crew ends up starting several months, at least a month before the vehicle arrives, pre-staging the hardware because they want this to be a very quick operation where the new hardware comes out of the vehicle and the old hardware goes back in and then the vehicle can depart. Therefore, you have staging the equipment outside the hatch, out of the way for the exit of the hardware, then you can turn around and put the other stuff back in. They thought they had enough stowage in. I remember in the very first safety reviews we had with Boeing, they said, we don't have the problems that the FGB has where they put things all over the racks. We have dedicated stowage in racks, and everything will be, we have planned stowage locations, but they were grossly inadequate. And where we are right now is our situation is just as bad as the Russian situation. So we're putting things in the aisles. It's mostly, though, we've limited it to the node 1, and we've made what I think are acceptable compromises to safety. We've covered most all the fire ports in the lab. We have not covered the critical emergency equipment, the fire extinguishers and the breathing apparatus, nor the clearance for the hatches. But we have covered up almost all the fire holes. And our acceptance rationale there is that because of an inefficiency in the fire suppression system of the lab, the fire suppression system didn't work that well anyway. So we did enhanced materials control behind the racks and said that they were a very unlikely place to have a fire to start with. And if we did have a fire, the fire suppression system was less than 100% effective. So if you're going to cover fire ports, the node is the place to do it. That's not the situation in the lab, because lab you can bring up experiments, you got more probability of having flammable materials. Therefore, it's a higher risk. So we prefer to keep the problem confined to the node right now, rather than have it migrate into the lab. But we're just at the beginning of station, and this problem, I said, if it's not corrected, is going to continue to grow.
I think in the future what we need to do is we need to plan for stowage, have a very good inventory tracking system, know what is our up mass, what is our down mass, and have verification and validation of the on-orbit configuration. You bring things up, and this has to be a crew-controlled item. You can't direct from the ground and tell the crew, this is where you shall place with no deviations items, because the crew is there. It's their living environment. They're going to be there every day. So they're going to put things where they're the least impact to them on orbit. And if you did tell them to put them in certain places, they'd probably change it because it doesn't work with the operations plan from day to day. So you have to leave the critical decisions in the hands of the crew. Likewise, you need to find out what the crew did. So you need video documentation of where they put things, what is where, and how do you find it. I think you got to consolidate stowage equipment, because as it builds up and you use things out of one bag, well, now you got a half-empty bag here and a half-empty bag there. Those aren't necessarily safety concerns, but it's increasing crew time. Like I said, operations is impacted long before you impact safety. From a safety perspective, we worry about aisle space and emergency egress, especially an injured crewman emergency egress, or if we had a fire or depressurization on station, ready access to leave that particular module, close the hatch. So anything that would hinder closing a hatch, closing a vent valve or something of that sort, so I couldn't isolate completely a module, was a safety impact. In the control and mitigation of stowage, I think you have to have a multidisciplinary approach. Don't just dump this in the hands of the stowage people and let them figure out a stowage plan, because the stowage affects multiple systems. So I think you need a multidisciplinary approach to it. And I think what we ended up doing by direction of the SSPCB was fill up the lab with cargo, or the node with cargo, and then tell me where I have to remove it. So we went up and did a mock-up, we filled it up, and then we said, okay, for safety purposes, for habitability, what do we have to move? For safety purposes, what do we have to move? And then we were left with which was available space. Now, we didn't want to fill up all that available space, but it's available space. And that gave us a context to look at and solve the existing stowage problem. That's what is the maximum upmass we can have and the total amount of cargo we can have at any one time. And let's not exceed that volume, because if we do, then we're exceeding the critical equipment requirements, or we're exceeding safety requirements or habitability. And so it's have a good plan of where you cannot put things. It's not where you can put things, because I think Murphy's Law will tell you you're going to have this problem sooner or later. So you got to know where you cannot put things. In fact, right now we're stowing things in the airlock, and when we go EVA, we have to take 15 bags worth or 32 bags worth of stuff out of the airlock just so we can go out and go to EVA. So that stuff is temporarily stowed all over the aisles until we finish with our EVAs, and we go back and fill it up the airlock again, because the airlock is only used when you go out EVA, and you're not doing EVA every day. The person who controls this is the crew on orbit, and I don't think we ought to put the crew in a situation where they're forced to make their own safety compromises. They ought to be giving the services to allow them to comply with the requirements. And if in this stowage area, you ought to make priorities and give those priorities to the crew so they can make sound safety judgments about where to put this stuff. Lately, it's been proposed, and I'm not in total favor of this, but it's been proposed that we jettison items from the station. I think you're creating another problem to throw things away. However, we have thrown things away. We're now developing a jettison policy on what can be thrown away and in what configuration, and what type of analysis has to be done to support the jettison. So there is a role that jettison is going to play in this stowage problem. The Russians jettisoned items. In fact, that's what started us on the philosophy of should we start jettisoning, because the Russians, when they were out EVA, when they finished with an item, they didn't even tell us about it. They just jettisoned it. And we said, no, you can't do that. And they said, we do it all the time, and here's our rationale, and here's why it's okay to do it. And they were correct. You know, there were no imminent hazards, but it's something that the NASA policy forbade, that we couldn't do that. And now we're trying to wrestle with the fact that it's probably a good idea, but we have to do it correctly and safely. And so we're trying to develop a policy to allow us to do that. Packing materials are one of the aspects of stowage that is often overlooked, because it has to be safe for launch, it has to take loads, and you want to protect the hardware, so you put it in these packing materials. Well, the packing materials end up being everywhere. So now you're dealing with the hardware item you brought up plus the packing material. And because of the orbiter problems we had as far as our accidents in Colombia and the tile incidents, we haven't had the logistics to the station that we wanted. So our upmass was coming from the Progress, and we weren't getting the large downmass from the orbiter. So all this stuff was accumulating, and I think we need to consider packing materials when we look at this. It has to be accounted for and disposed of, just like the unused hardware that we're bringing up.